moments and tilting. Example 3. So we have a uniform beam of mass 45 kilograms. So the weight is 45 g, and because the beam is uniform, it's right at the center, and this beam is supported at C and D. And the distance from the end of the rod here to the support at C is not the same as the distance from this end to the support at D. And neither is this distance the same as this. Now a child stands at one end of this beam and the beam is about to tilt. The mass of the child is unknown. If the beam was to tilt, the pivot point would be at C. And when the beam is about to tilt, the reaction force at D will be 0. At this point, support D is actually doing nothing, so if it was removed, the beam would be perfectly balanced. So there are various measurements, the weight of the child, the distances, they're all missing at the moment in this diagram. If we add them all in, we have this diagram, and we already know at the point of tilting, the reaction force at D is 0, that's been mentioned already, and if we take moments about point C, here our pivot point, so the 45 g force will create a clockwise rotation. So because I'm taking clockwise as positive, that's a positive moment, and the perpendicular distance between here and here is 3 meters. And it's 3 meters because the length of this rod is 5 plus 9 plus 2. That's 16 meters. Because it's uniform, the 45 g force is right in the center, so it's 8 meters from this end to the center. So 8 minus 5 gives you 3 meters in here. Now the mg force, the weight of the child, so the arrow points down, so about C, that creates an anti-clockwise rotation. So force times distance, 5 times mg, and it's negative. And then we have the normal reaction at D, the perpendicular distance from point C, but the normal reaction at D is 0, so that's not going to do anything. So we have an equation to solve. We solve to get m, the mass of the child, as 27 kilograms.